Okay, so yesterday I have given you a simple task. Why the three methods that we are talking about since yesterday? What are the three methods? Notify method, wait method, right? Wait method. So you have five methods totally. Notify all, wait, and there are two more overloaded methods. One wait method, it accepts an argument as milliseconds, and another wait method accepts two arguments. One is for milliseconds and second argument is for nanoseconds. Okay, so all these five methods are part of object classes, or no? Do you know this?
Yes, sir.
These are the part of object class. Why Java has placed these five methods inside the object class but not in the thread class? So there is a dedicated class to handle multi-threading concepts, right? So you have a class called thread class. Thread is, and again the thread class and the object class, they are given in the Java library. So why can't these five methods, never a part of thread class, but why did they place inside the object class? Okay, inside the thread class you have so many things, right? You have run method, and you have join method, you have what? You have yield method, okay, and so many methods. Sleep method, I mean thread dot sleep method. So many methods are there, which are part of thread class. But it will make more sense because this notify all, wait, these concepts are related to multi-threading. Yes or no? Hello? Don't you think that these
Yes,
methods
sir.
are completely related to multi-threading? So why they are not part of thread class? Why are they part of object class? Any idea? Anyone done any research on this?
Mainly synchronization.
Synchronization, and again, okay, it can be part of thread class, right? Why it is part of
Yes.
object class? Why? You are getting my question, right? Synchronization is okay. Synchronization is always a topic of discussion on multi-threading, right? If that is the case, why did they choose the object class to place this method, not the thread class? Tell me one thing. Don't you think that this object class is the super class of all Java classes? Even this thread class also indirectly extending to object class. Yes or no? The super class of thread class is
Yes,
also an
sir.
object class. Do you agree with that? Hello?
Yes,
Thread
sir.
class also super class object class. So why they are not being very specific is, let me tell something. See, let me give you a small program. Remove this. Let me also remove this. Not required. Okay, before that, let us say I have three different classes. One is what? One is student class. Okay. Second one is the employee class. Okay. And the third one is something like, let us say that I have another third class, A extends thread. Okay, I have an independent class which is A, and again it is extending the thread class. The third class is I have something like A1 equal to new A. Okay, so based upon this reference variable, you can say which is a thread class right here. S1 and E1, they are not thread classes, or no? These two classes are not the thread class. Do you agree with that? They are completely independent.
Yes, sir.
But if you look at A1 equal to new A, okay, even though A is an independent class, but it is extending to thread class. It is going to get all the qualities, all the behaviors, and all the properties of thread class. So I can say that A1 is what? A1 is completely a thread class reference variable. Do you agree with that? Okay.
Yes, sir.
On top of A1, you can do all operations. On top of A1, you can call join method if you want. What join method is going to do? Join method is going to do what? It is going to wait for the particular thread. Okay. On top of A1, okay, you can call the start method. What start method is going to do? Start method is going to execute the run method inside the thread object. Yes or no? Hello. So all the
Yes.
basic functionalities, okay, whenever you're getting an object reference, when the reference is part of the thread class, you can call join method, you can call start method, you can also call the yield method. Okay, these are completely respect to the methods inside the thread class. But when you talk about the independent classes, so S1 is an independent class, it is not a thread class, and here C1 is also an independent class, it is not a thread class. Okay. On independent class reference variables, you can call notify all, wait. It doesn't need to be a thread class. Are you able to understand little bit difference now?
Yes, sir.
It should not be, it is not like, okay, we have to guarantee, it is not like we have to give a guarantee that you can call all these object only on the thread class. It is not like that. You can call all these methods, you can call all these methods on any reference variable, on any class reference variable. It is not specifically like you have to call, you're supposed to call only this method on top of thread class reference variable. It is not like that. You can call all these object on any class. It can be a student class, it can be an employee class, okay, it can be any other class, it can be B class, ABC class, it can be string class, it can be any other class. That flexibility has been given for this notify all, wait method. That's why they have placed this in the object class. If it is like, okay, this methods needs to be called only by the thread class reference variable, if that is the situation, definitely don't you think that these methods will be placed inside the thread class and keep it very much secure, so that only a1 can, in our case only a1 can call all these methods, yes or no? Hello.
Yes, sir.
I will give you one small example on this. So let us say, let me say, okay, let us say I have a student class, student. Okay, let us, the name of the class is driver class. Let us say driver class, driver d1 equal to new driver. Okay, d1 dot wait. Okay, now tell me how many threads are present in our, if I execute, if I run this code, how many threads gets activated?
One thread.
Only one thread, which is what? Main thread, yes or no? Main thread will come into the picture. Okay, now what happens if I run this code? Do you think that main thread will wait forever or what do you think on this statement? What do you think the output is going to be? Okay,
It will wait for us.
okay, let me say, okay, going to start wait method. Okay, so what do you think output is going to be? Going to start wait method. This is what your understanding, right? Yes, no?
Yes, sir.
Okay, if I run this code, okay, what do you see? This line number 10 is getting executed successfully, but what exception you're getting here? Runtime exception. What exception you're getting here? Java.lang.illegal monitor state exception. Now focus here. Why this exception is getting thrown? The question is why this exception is getting thrown. Java.illegal. So do you remember yesterday I said somewhere in the middle of the program, I said somewhere that wait methods can be used only in the synchronized area. Do you remember or not? You can
Yes, sir.
use the wait method only synchronized. Do you think that this is a synchronized area that we have here? This is not a synchronized area, isn't it? So when you do such violation, when the wait method is called inside a non-synchronized area, you get an exception called what? Java.lang.illegal monitor state exception. This is one takeaway. Second one is, I know this wait method. Okay. So this driver object is a thread object or what?
No, sir.
It is not a
Not
thread
one.
object, right? But you should be able to call the wait method. Let me place this wait method in the synchronized area. Let me take my own synchronized area to understand this. Okay, my synchronized area is going to hold the lock of which object? Lock of driver object. Okay, inside this, what I am doing is I'm printing something like going to call wait method. Going to call wait method, and I'm just using the reference variable d1. D1 is of what type? Thread type or non-thread type? non-thread type, right? If I just call wait method, just tell me, do we get exception or not here? Think the takeaways that we have just seen. What is the takeaway that we have just seen? Wait method is placed in the synchronized area. Valid or invalid?
Valid.
Valid, right? And synchronized block is accepting what object? Thread object or non-thread object?
Non-thread.
Non-thread object. As per the definition, as per understanding, it is valid. But the problem here is this wait method will never, I mean, the thread, okay? What thread is acting inside the synchronized area? Which thread is going to act inside this? Thread is going to get access to the synchronized area? Main thread, right?
Main thread.
Main thread. Now main thread will be part of synchronized area. Now what is happening behind the scenes is, let me copy this. Okay, this understanding is very important to understand consumer producer problem. Now see, okay, you have one thread, a main thread. Main thread is creating an object for the driver class. Okay, an object is getting created. Object is getting created. So this object is going to, every object has a monitor and which is going to have a key, right? So now what is happening? There is a synchronized block which is accepting a lock, which is accepting a D1 lock. So this is D1. Okay, this is D1 object. Okay, so let me use lock. Okay, lock monitor. You have the lock. Okay. Now the lock will be acquired by which thread? Main thread only, because there is only one thread. Main threads acquire the lock. Okay, so lock has been acquired by the main thread. Okay, main thread gets into the synchronized block. This statement gets executed. Yes or no? First statement will be executed. Next, after the second statement, what is happening? Main thread is going to wait because of this condition, because of this wait method. Wait method is getting called on the D1 object. This is a D1 object. Okay, wait method is calling getting D1 object. So don't you think that the lock will be released by the main thread as soon as it encounters a wait method? Hello.
Yes, sir.
Now the main thread will be in the waiting state only to get notified. It will be thinking that someone will be notified. Yes or no? Until that, it will be the waiting state. Now tell me, according to the thread scheduler, we know what is thread scheduler now. Thread scheduler. Do you think that thread scheduler will even take care to call the thread that is waiting? Will it give a chance to the waiting thread?
No, sir.
Thread scheduler will never give a chance to wait. So in this case, the waiting thread is going to wait forever, right? Yes or no? Hello?
Yes, sir.
Now let me run this. You see what is being printed in the line number 12. Okay, after that, if you observe the terminate button, okay, the terminate button should not get highlighted here. If it is getting highlighted, it means the program is running forever. Even if you come back after 1 year and if you see, making sure that the power is on and everything is okay, okay, the thread keeps waiting forever. Okay, so what they have thought, what Java people have thought, to avoid these situations, okay, they have given the timed waiting. What is the timed waiting? Okay, you can give some time, you can give some instructions to the main wait method saying that you do not want to wait until you need to receive the notification, right? Sometimes there are high chances that you may not receive the notification, so that you do not want to wait forever. You can wait up to 1 second or wait up to 5 seconds. If you're not getting any notification, you can resume your work. Okay, wait, main thread is resuming the work. So what happens? So if you go by this code, okay, the lock will be given to the main thread is going to release the lock only for how many seconds? Only
5
for
seconds.
5 seconds. After 5 seconds completed, okay, the lock will be again acquired by the which thread? Acquired by the the thread that is waiting. Yeah, main thread. Okay. But it has to ensure that, it has to make sure that the lock is available. So how the lock will be available here? No other thread is supposed to use this lock. Until that, it will be in the timed waiting. Until that, okay, instead of waiting, now because of the parameters that you have passed, the state becomes what? The state becomes the timed waiting. There is a lot of difference between the waiting and the timed waiting. This is also one of the state. This is also one of the state inside the life cycle of a thread. You just use wait method, it is just waiting. If you use timed waiting, it means it is going to wait until a certain period of time. Okay, once the lock is there in the monitor, once it sees that lock is there in the monitor, it acquires that lock immediately. Are you able to follow? If some other thread is using this lock, it will wait, okay, but it is ready to acquire this lock. For example, let us say that T2 is somewhere T2 is using this lock somewhere. Okay, the main thread has waited for 5 seconds. Okay, it is ready to acquire this lock, but the lock is not there. As soon as the lock is released by some other thread, it is going to consume, it is going to acquire. Able to follow?
Yes, sir.
Right? Now this is what the job of overloaded wait method, and one more overloaded wait method which is consume, it is going to consume 2 arguments. Okay, this is simply means for to be very specific. Okay, you can define the nanoseconds time also. It is same like wait method. Okay, if you run this code also, you will see the same output. There is a time delay here. We don't visualize that completely. Able to follow? Okay, after the main thread started resuming its work, synchronization block will be completed. Main thread comes out of the synchronized loop. Then what happens? Main thread gets terminated. Yes or no?
Yes, sir.
Okay, now same thing. Okay, same thing. Okay, instead of wait method, if I just use the notify method, okay, notify method is used in which area? First tell me. Notify method is used in which area? Synchronized or non-synchronized area?
Synchronized.
Synchronized area, no issues. But if I start using notify method in the non-synchronized area, what exception we have to get? Illegal monitor state exception, right? Able to follow? So both wait method and notify method should be used only in the synchronized area. First conclusion. Second conclusion is you can call wait or notify method on any Java object. It is not necessary it should be the thread object. You can call them on any Java objects. That's why they have placed these methods in the object class, not in the specific thread class. Able to follow? Hello?
Yes, sir.
Now what happens if I run this code? If I run this code, you don't see any difference. At the same time, the program is not running forever. Why the program is not running forever means notify method, okay, just it does what? It just gives the lock and the thread is going to die. Yes or no? Which means the thread has completed its job. Thread has completed its job. Okay. So the lock will not be released immediately. If there are any other resources inside the synchronized area, that will be completed. Okay, that will be completed, then the lock will be released. Okay, after releasing the lock, it means that it has completed executing its instructions. Able to follow? That's why you're not getting it. Even if you start using notify all, I will tell you the difference between notify and notify all. Okay, notify means, for example, okay, let me start analyzing in different way. Let us say that you have one object, guys, one student object. Okay, let us say this is an S1. This is what S1 object. So inside this S1 object, okay, this is one common object. Okay, let us say that you have 100 threads. 100 threads. Okay, 100 threads are trying to use this common object which is S1. So how many logs will be there? Only one log will be there, right? There is a monitor. Inside that monitor, there is a log. Okay. Don't you think that out of this 100 thread, at any point of time, only one thread, let us say the thread number 89. Okay, we'll acquire this log. At any point of time, only one thread get access to this log. Yes or no? At any point of time, due to the synchronization.
Yes, sir.
Do synchronization at dependent time, only one thread is going to acquire this lock. There are 99 threads remaining. There are how many threads remaining? There are 99 threads remaining. Okay, let us say that the thread number 89 has encountered the wait method. Thread number 89 has encountered what? It has encountered the wait method. Okay, and out of these 100 threads, let us say that the thread number 50. Okay, inside the thread number 50 is trying to access a synchronized area which has the notify method. Let me put it here. Which has the notify method. So as soon as it notifies, okay, the thread that is any after this, okay, let me say the lock has gone from here to here. Okay, so you have one active thread number 89, and you have one more thread number 50. So 89 was the thread that was holding the lock. Okay, and because it has encountered the wait method, the lock has been released and it has been given to your thread which has the notify method. Right? So as soon as the thread number 50 encounters the notify method, the lock may not get released immediately, but after some time the lock will be released. So don't you think that we are not sure, okay, out of this 100 thread, we are not sure which thread is going to get the CPU time, or thread scheduler may activate any one of these threads, yes or no? We are not sure, right? Out of 1 to 100, we are not sure which thread is going to acquire this lock, because it depends upon the CPU time, yes or no? Hello?
Yes, sir.
Depends on CPU. Let us say that, okay, thread number 44 as for the CPU time, definitely it will take the lock. It will perform the instructions. So if these things are happening, okay, now you have 100 threads and all these things are happening on only one common object, which is a student object. Okay, now if you, instead of notify, if you just use the notify all, okay, there might be high chances that T1, T2, T3, T4, T5, T6, T7, and some random threads. And just all these threads might have called the wait method at some point of time. Every thread is eager to what? Eager to get notified. Every thread is eager to get notified. Okay, but if you just use notify method, notify method, due to the CPU time, only one thread may get notified due to the CPU cycle. But if you use notify all these waiting threads will be cleared. Are you able to follow? You can understand this programmatically. I will explain this program. Are you able to follow? Notify all means it is going to notify all the waiting threads. Notify means it is going to notify any one thread at any point of time. That is the only difference. You can understand this programmatically. Are you getting the basic idea now first? What is what?
Yes, sir.
Yes, sir.
Let us design a program. On top of the program, we can understand this very much better. Let us take a class student. So student is going to have what? String name and integer age. Okay. Let me generate constructors using the fields. Source generate. Sorry. Source generate constructor using the fields. Okay, let me also generate getters and setters. Source generate getters and setters. Getter. Okay. So I'm going to use this student as the common object. The student class is going to be the common object. For what? Let us say that Let's try to understand that student is getting an admission in the college. Okay, class. Let us say there is an attender class. Attender class extends that class. Okay, this attender class, inside this you are going to keep the common object. What is the common object that I am talking about? I'm going to keep the common object inside the attender class as well as the accountant class. I will take another class. Okay, this is the common. I'm just keeping the reference. Student. After this, let me generate source, generate constructors using fields, generate. Okay, attender constructor, and I can override the run method. The run method has been overridden. So inside this run method, okay, I am going to take a synchronized area. Okay, the synchronized area is going to have the student object log. Have you understood so far what I'm trying to do? I have simply taken a student class, guys. It is going to be a common class. So if you want to visualize that, I have taken a student class. Okay, I'm going to create an object for the student class, which is going to be the the common object for all the threads. Okay, the student class as a state here. When I say state, what is a state here? Name state as well as the age state. Okay, after this, what I want to do here is, okay, so I have taken an attender class. Okay, attender class is going to have the student object as a reference, and I have overridden run method. Why run method? Because my attender class is going to start a thread. It is going to start a thread. Okay, so inside the student class, I'm going to keep a simple instruction here. System.out.println student. I'm going to fetch the name of the student. Okay, plus student dot age. After fetching name and age, what I am going to do is I'm going to release the log. I just want to release the log. When I want to release the log, I can call the wait method. Okay, it is going to throw the I am surrounding with try and catch block to handle this exception gracefully. Then after this, so once I get notified, what I want to print here is again I want to print student dot name plus student dot age. Okay, so there is a wait method. Wait method is applied on which object? Student object, right? Student object is a thread object or non-thread object? Hello?
Non-thread.
And wait method is there in which area? Synchronized or non-synchronized? Synchronized area, because synchronized inside this block you are keeping the wait method. Right? Now, so you have created the attender class and you are creating what? And again one more class, accountant class. Accountant class extends the get class. Okay, and again this accountant class is going to make use of the common student option. It is like we are just trying to do the inter-thread communication. Okay, just imagine it like student has approached a college. Okay, inside the college, okay, he has visited one person, another person. First person is the attender person. Okay, attender has taken his name and he has taken his age. Okay, and he went inside the college. Okay, instead of attender means, let us say that a kind of security guard. Okay, let us assume it like a security guard. He has taken his name, he has taken his age, okay, and he allowed the student inside the college premises. Inside the college premises, okay, let us say that there is an actual accountant person who is giving the admission to the student, okay, and he is taking the actual name of the student and actual age of the student. Okay, I mean maybe the attender might have taken the corrupted value and he might be accountant person might be correcting that value and giving a notification to the attender that this is the corrected value. Once you see these values, you can open the gate for the student. A simple analogy. Okay, so they both are communicating on the common object, which is what the student object. This common student object is going to have a lock. Common student object is going to have a lock. The question is how these two threads, how these two persons, how these two threads. Okay, let us say that this is thread 1. Let us say that this is thread 2. Okay. How these two threads are going to communicate? How they can communicate? Only by accepting the lock. Okay, if the thread 1 starts its job, okay, the student has to approach the attender first. Okay, he has the attender, the thread 1 acquires the lock. Okay, after some time, after getting the data, okay, it encounters a wait method. As soon as it encounters a wait method, this lock will be given to the next thread. Okay, the accountant will collect the complete information, okay, and releases a lock by calling the notify method. So don't you think that, okay, there are the concept of wait and notify? Because of this wait and notify, the two threads can gracefully communicate with each other by acquiring and releasing the locks respectively. Hello?
Yes, sir.
Means wait method, it is just like, okay, when the thread is encountering the wait method, simply means that lock will be released and it will be waiting until the notification is received. Okay, when the thread is encoded in the notify method, it means it has done its job. Its job is to give the notification to the waiting method. This is how the two threads communicates on the common object, which is the student object, so that the data of the student object cannot be corrupted, right? And the communication is happening gracefully and the properly. Are able to understand, apply this to the real-time analogy? Are able to visualize this? Yes, no?
Yes, sir.
Okay, so now accountant, okay, accountant is also expecting the student, okay, they want to work on the student. Okay, source, generate constructors using fields. Okay, and again there is one more run method. So inside this run method, so what this accountant is doing, okay, is accepting the student object dot set name. It is setting a different name, means student dot get name plus okay. So what it is doing? So let us say that the attender has collected the student name as Balaji and the age is 25. Okay, and the accountant has modified the collected name. Modify the collected name. Modification means, okay, he collects the name and he also takes the surname. A proper the object is getting constructed properly. The object is here. The object is getting constructed properly. Okay, this write operation and the read operation, okay, you are indirectly doing the write operation, read operation, but not at the same time. Both are happening at the different times. They're not getting updated at the same time. If they are getting updated at the same time, there will be a data inconsistency. You are avoiding that. You are not aware that you are using the you have chosen the synchronized area, which will ensure that only one thread get access. Okay, the attender as he started writing the data. He consumes the data and he gives it to the accountant. Accountant corrects the data. We will understand that programmatically. After only changing this, okay, he just giving the notification. Okay, so I want to use this in the synchronized area, right? Synchronized area, student, Inside this, he did these changes, and after doing these changes, he's calling the notify method. Notifying the what I am doing. So I am taking the main method. So inside this main method, let me create an object for the student. Student s1 equal to new student. Okay. So I'm going to pass two names here, Balaji. Okay, two values here, Balaji and 25. After passing these two values, this is going to be a common object. Okay, common object. On this common object, the two threads are going to communicate. So what are the two threads that are going to communicate by just using the common object? So one is the attender thread, second one is the accountant thread, right? So attender thread, attender at equal to attender. Okay, so attender is going to act on the student object. So I'm passing s1 here. Okay, likewise accountant at equal to new accountant. Accountant is also going to accept the common object, which is student object. When A select, take AC. If I do at dot start and AC dot start. Okay, so now you tell me on line number 88. So one thread will be started, yes or no? Accountant thread, I mean attender thread will be started, yes or no? Hello?
Yes,
Along with the attender thread, main thread is also alive, right? Main thread is also there. On line number 90, accountant thread gets started. Okay, and the main thread will be focusing on the remaining lines of the code, remaining lines of the method, right? So if I just run this code, okay, now what happened is accountant has called in the beginning. Now there is a problem. What is the problem is we are not sure how the job of the scheduler will be, right? Thread scheduler may give a job to accountant first, then we can later think about giving the job to attender. If accountant is getting a job first, what will happen? Okay, the attender will end up in infinite waiting loop. Infinite wait, right? Sir, no? When accountant is executing this area, okay, which means accountant thread has got the CPU cycle. Okay, this data gets printed, no issues, right? And it is going to call notify. It has done this job. Then later the attender may get this CPU cycle. If that is the case, on line number 46, it means it has to wait forever, right?
Yes, sir.
So this is called as what? This is called as a kind of situation that we have to avoid. We should not. So to be in the safer side, if the what we call it, if the notify method is getting a chance first, now we make use of what? We make use of the timed waiting. If you make use of the time waiting, even though the accountant is getting a chance first, definitely there is no issues with the attender, what we call it as the wait method as well, right? The thread that is waiting on the synchronized area will not be in any trouble, right? It will resume its work after waiting for some seconds, yes or no?
Yes, sir. After 1 second.
After 1 second, in our case after 1 second. So now see Balaji, okay, notifying the attender, and Balaji surname 25. Balaji 25, which means this is called, and there is a timed waiting here. Now attender is notifying the attender. Okay, let me keep some statement here. Meaningful statement. Waiting block. Okay, and system.out.println notify block. Here on this. Okay, notifying block is getting called first. This line. Okay, then notifying, okay, the data is getting set and this is getting printed, notifying the attender. Then the control comes to waiting block. Okay. Then the data is getting set. Instead of doing this, what we can do, we can also do something like this. We can ensure that the notifying block is ready. Okay. Waiting block is getting a chance, data. Notifying block is getting a chance, notifying the attender. Okay, so what is happening behind the scenes? We will do the tracing part completely. All your doubts will be cleared up. Okay, this is our code. Let me separate this. So I have to separate two things. A student class, you have the driver class, and you have what? Or some attender class, and you have this. Okay, let's start from the main method. In the main method, what values are setting? Tell me. Balaji 25, right? So student object is getting created, and this is the student reference. Okay, name is what? Name is being set to Balaji. Okay, age is being set to 25. Okay, the job is done. Okay, from here, okay, and you are just creating. You are just creating a new thread, AT and AC. Okay, and from here, AT is getting started. One new thread is getting started, and it is by the name of what? By the name of AT. So this is AT. So this AT is getting started from the line number where? From the line number, I mean from this line. From this line, main thread, along with the main thread, the AT thread is getting started. Okay, and from this line, from the very next line, okay, AC dot start. Okay, along with the main thread, okay, one more thread is getting started. This is AC. So both are mean to. Do you think that both threads are mean to execute its respective run method? Yes or no? Hello. So this method will be very much ready to 80, right? 80 means attender. Very much ready to execute the run method of the attender, right? And this method is also very much ready to execute the run method of the accountant. But the question is, it depends upon the CPU side. It depends upon the thread scheduler. That is the actual boss. Thread scheduler, we are not sure whether the thread scheduler is going to give the job to AT or AC or the main thread. There are three active threads here. There are three active threads. So let us say that thread scheduler is giving a chance to what? It is giving a chance to AC here. It is giving a chance to AC. AC is getting the time to sleep here, 1 second, which means 1 second is a huge amount in the computer programming language. It is a very huge amount. Okay. Immediately the chances will be oscillating between the main thread and the attender thread. Yes or no? If the accountant thread is sleeping, definitely either the chance will be oscillating between these two threads, right? Hello?
Yes, sir.
Because 1 second is huge amount. Let us say that okay, AT is getting a chance or MT is getting a chance. If MT is getting a chance, it has completed executing all the instructions in the main method. Who knows, it may be what? It may be terminated. Before terminating it, it will ensure that all other threads are dead. Then only it will get terminated. Let us say that it's in the last line. Okay, if it is a last line, then only AT is there. AT will get a chance now. Okay, now AT is getting a chance. So still you have 1 second. 1 second is a very huge amount. 1 second is a very huge amount in the computer programming language. 1 second, very huge time, very huge time. It's not a small time. It's very huge time according to computer program, right? So it will use this 1 second and it will execute the waiting block. First instruction, waiting block. Okay, this will be statement will be displayed. Second instruction, it is just extracting the name and the age of the student. What is the name and the age of the student here? Okay, Balaji and 25. Okay, this Balaji and 25 will be displayed comfortably in the console, right? Hello. Before that, one more statement was left, which is what? Waiting block. So first is waiting block. Next one is Balaji and 25. Right. So this is the data. This is the actual data that is already set. Okay. Now let's go back to the control. 1 second. Still 1 second is there. Okay. And thread means student dot wait. Okay. Now AT will be in the waiting state. Yes or no? AT will go into the waiting state. What does it really mean? If it is going to the waiting state, the lock will be released, right? The lock will be released. And which is the other thread that is acting on the same student area, same synchronized area? Accountant, right?
AC.
Accountant, right? AC, correct, AC. Okay. Now AC might have woken up because the attender started to wait. AC might have woken up. Okay. And it will encounter this what? Notifying block. So notifying block will be displayed in the console, right? Now after this, what happens? Okay. What it does here is, focus here. It is changing, it is modifying the value of student dot, setting the name. What name it is setting? Okay. It is getting the name from the memory. Student dot get name. Get the name from the memory. What is the actual name in the memory? Balaji. And concatenate the name, which is actually what? The surname. Okay. This data will be changed inside the, what we call it as the rewritten. Name becomes Balaji surname. Any surname you can take. After doing these changes, okay, it is calling the notify method, which means the lock will not be released immediately. Yes or no? After completing all the instructions in the synchronized area, lock will be released, right? So what is the last line? Notifying the attender. Okay, notifying the attender. Okay, then lock will be released. Okay, accounted thread will die then and there, will get terminated then and there. Lock will be released. Lock is releasing means what? Now instead of the thread that is waiting, now it will get activated. Okay, AT gets activated. Okay, and it has only one instruction which is remaining. It will get the name of the student from the object, from the common object, and print the name and the age. So what is the actual name of the student in the common object? Balaji surname, right?
Yes, sir.
Balaji surname and 25. Okay, after printing this, okay, even this thread will also come out of the loop. This thread will also die, get terminated. After these two threads get terminated, main thread will also gets terminated. Okay, then JVM will get shut down, program completed. But if you see the console, you see what? Are you seeing the same output, right? So we are able to give justification for this output, right?
Yes, sir.
Understand it? So who is responsible? Okay, developer, programmer should take care. The CPU cycle is happening between the wait and the notify, but the wait should get always the top priority. That is our understanding with this example, right? How we can ensure that wait is getting the top priority? Just by using all this. Okay, we can use thread dot sleep here. Okay, we can push the some more deep concepts are there. Priority threads. You can give priority to a particular thread. Okay, the thread that is in the topmost priority will be getting the first chance to execute the instruction. Thread scheduler will be giving a chance to the priority thread to execute first. You are not required to learn all this. So the high level priority threads are there. You have min priority, you have max priority. You can pass some priorities. Okay, so don't you think the developer is responsible to ensure that when there is an oscillation between the wait and the notify, wait method should always be invoked first? Yes or no? The notify is getting
Yes,
invoked
sir.
first. What happens? Okay, the other thread will be waiting forever. To avoid that, what we can do? We can use what? Timed waiting. That is one more time waiting. If you do not want to use time waiting, also you can use what? You can use thread dot sleep here. Anything that is very much meaningful and very much saving your CPU time, program time. You can go for that. But here the concept is not about who is getting a chance. The concept is all about how two threads are communicating with each other. Making any sense? Hello?
Yes, sir.
Yes, sir. Understood.
Understanding, right? Okay, now you see, now let us go back. You have been wondering about the notify all, isn't it? So let us say, here you have used notify. Okay, so what I can do here is, let me see. Let me take another attender. Let us say that there are two attenders in a college. One and two. Two attenders. You are starting 81 and 82 dot start. So how many threads are totally there?
4.
Along with the main thread, 4 threads, right? So how many threads will get access to the synchronized array at any point of time? Only one. Okay. If 80 is okay, 81 is on this area, 82 has to wait for its CPU cycle. Yes or no? And the account AC thread should also wait until it gets a CPU cycle. At any point of time, no matter, even though you have many synchronous areas separately, all are using the common lock, which is what student lock. Okay, student class has only one lock, right? This one lock will be shared among these three areas. Three areas in the sense, the attender will get again a copy of attender separately. Copy of attender will be there because you have created another attender object. A copy will be there. It's just like this, guys. So what we have done so far is, okay, let me say, you have the common student object. You have created two accountant class, and you have created one notify. Two attender and one notify. 81 is 82 is AC. So this is student. How many logs an object will have? Only one log. Thread scheduler will ensure that because of the CPU cycle thread scheduler, we ensure that any thread will be getting this log at any point of time. Okay, from our example, we have what? So 81 as the wait method, yes or no? 82 is also having the wait method, right? And only AC as the notify method, yes or no? Hello?
Yes, sir.
Only this has the what? Only this has the, the notify method. Okay, let us say that the 81 has gone into the waiting state. Okay, let us say that this 81, this 82, both have gone into the waiting state. So due to our internal design, we are making the notify thread to wait for 1 second. So because of that 1 second, this 81 will also be in the waiting state. This 82 will also be in the waiting state. Okay, if I just call the notify method, now think deeply. Let me put in a different. This is 81. This is 82. So we had made this a thread that is calling on notify method to wait for how many seconds? 1 second. Do you remember? 1 second. It will wait 1 second, right? It means within this 1 second, the thread cycle definitely will give a chance to 81, 82 occasionally, but definitely both will go into the waiting state. Yes or no? 1 second is enough. The other threads can act very fast. Okay, other threads will get an opportunity very fast on thread scheduler. Both will go into the waiting state. Both threads are going to the waiting state here. Focus here. Both threads are going to the waiting state. So 81 is going to the waiting state. 82 is also going to the waiting state. Okay. Let us say the 1 second is completed. Okay. Now notify method has completed its executing its work. It has got a chance. The notify method has got a chance by the thread scheduler. If it is only notify, remember, it is only notify. Only depend upon the thread cycle. We are not sure whether the thread is going to invoke this 81 or 82. Let us say that if it is invoking 81, which means the lock will be given to 81, but this 82 will be waiting forever. Able to understand what I'm trying to say? Because of the thread scheduler, the issue is happening here. Thread scheduler can give the waiting, it can give the chance to any one of this waiting thread. We are not sure whether 81 will get a chance or 82 will get a. Let us say 81 is getting a chance. Lock will be acquired by the 81. Lock will be acquired by, because only one notify lock is released and lock is acquired here. Is there any chance that this other waiting thread will get a lock because the thread scheduler will never worry about this, right? This thread is going to wait forever, right? Okay, let me show this. Understanding this is very difficult. Let me show this. Let me run this. Okay, let me run this code. Now you see the output. Some output you are seeing here. Are you able to see the highlighted terminate button here? Which means our code is still running. You know, one of the thread is still waiting, you know, forever.
Yes, sir.
Yes, sir.
Okay. Now in this case, in this situation, you don't use notify. You use notify all. If you use notify all, the problem is solved. Okay. Again, what happens? Okay. Let me make some time. Let me ensure that this is also waiting for some time. Without sleep. Okay. Now the problem is solved. Why I made thread dot sleep here? Might be this might have got the chance first. You know, before this, they're not sure. I'm making the start method to get delay for 2 seconds, so that these two threads will go into the waiting state. Okay. After that, this is going to get started. Okay. And it has encoded the notified all, which means all the two waiting threads will get released now. No issues. Are you able to follow?
So you can simply make timed wait now.
Which one?
Instead of normal wait, you can make timed wait.
We can make timed wait also, no issues, but we are trying to understand about the importance of the notify all method. So since we are now dealing with only 2 threads, no issues. Tomorrow we might be dealing with 100 threads. For 100 threads, if we keep time waiting, performance will be down, right? Every thread will wait for 1 second, no? 100 seconds will be wasted, right? I will understand.
Yes, sir. Yes, sir.
Time is wasting now, so that time we can have to avoid. So notify, now you understood what is notify all. It is releasing lock. I mean, it is ensuring that all threads are getting awakened, right? At a single point of time. Just do a research on this code. I will share this code. Just do a little bit research. Yeah, thank you for rejoining. Okay, what I'm saying is just do a little bit research on this code. Okay, take pen and paper, try to do the tracing, and try to see, why did I choose the thread dot sleep some areas. Okay, and now if you just keep tracking this, think about the thread scheduler like a person, because the scheduling will happen randomly. Okay, keep an eye on that and design the code in such a way that there is no forever waiting for any threads. Are you able to understand? I think I have shared the code. Okay, just do this, you will get the complete picture. After doing this, tomorrow we start producer and consumer. One problem is a producer and consumer. That's it, Java will be completed.